Well, hello everybody, and welcome back to the bench. And our next project here is another vintage Pioneer. Honestly, guys, I do work on more than just Pioneer, but these are popular machines. I get so many of them. This is an older one. This is an SX525, and I think it's rated only somewhere between 10 and 15 watts per channel. But as you see when we get into this, you're going to be surprised how well built this is for something that's, you know, such a low rated, low power rating on it. It definitely not a low build quality rating though. Very well built. This one's, the owner says that it's got some issues. Some of them are intermittent. Some of them only show up after it's been on for a while. I took it apart real quick and just did a preliminary for him before we decided whether to restore it or not. First thing I noticed was one of the capacitors was getting warm as soon as, right after you turn it on, meaning it was either trying to form up or it was already shorted or leaking and is going to fail shortly. So this is definitely a system that's in need of a recap. And you're going to see that this design on this is a little bit different than some of the other ones that that we've worked on in the past. So the circuit design, the service manuals do not provide you with a procedure to do the bias settings, so that's something we're going to have to figure out. And as you're looking here, I'm kind of on handheld camera for a minute because I want to show you this. I've come up with another little different addition to my camera mount. So my camera is mounted on a little arm, and it can articulate a little bit, and then this clamp that goes into it can slide back and forth, so I can move the camera at an angle to get it out of my way or to get a more angled shot. I also have a tripod here with one of my other cameras attached to it, and that's going to be, we might do some picture-in-picture dual camera. I did this once before to be able to aim that at the test equipment so you can see me doing the service and see the results on the test equipment at the same time. I'll see how much of a hassle it is to do all this. The editing is getting longer the more things I add to it to make it a little nicer. But as long as I have the time to do it, I don't mind sharing with you guys a little bit. So that should be some fun things to try. But let's check this thing out, get it apart, and see what's happening with it. I will get it connected up, and I really don't want to play this because I already played it a little bit and those capacitors were getting warm, or at least the one was. So I really don't want to cause any damage in it. So I think this one, other than doing a preliminary test, we're going to actually start by just taking it apart. Okay, so let's get it cracked open and see what it looks like. Okay, we've got the receiver apart, and we've got a whole bunch of people in the house today, so you're going to hear all kinds of footsteps and things. So you're coming into my house when you're here. So with what I'm hearing, you're hearing. So anyways, so let's take a look at this. One of the things that you notice right off the bat for a small output amplifier, look at the large heat sinks they use on this thing. I mean, they spared no expense on these. Very good quality, very good design, very thick aluminum. Yes, they're using that weird liquid heatsink compound. It does work really well, but when it dries out, you can't get it. It's a lot of work to clean off. So as long as I'm getting good thermal conductivity, I'm probably not going to take it off. It's permanent. It doesn't deteriorate. It doesn't dry out like the paste does. So it doesn't break down. It just pretty much is permanent as long as it doesn't flake apart or anything. Also, these little diode arrays here are glued to the heatsink using that stuff, so I really don't want to disrupt them or damage them. So we're probably going to leave well enough alone with those. Now all these caps are going to get replaced, and the reason they are is because, like I said, when I turn this on, I usually go around to the power supplies and some of the things that have higher power on them, and I just go around and kind of feel them. Now, you better know what you're doing if you're doing this, okay? Anytime you touch circuitry that's live, you run the risk of electric shock. So make sure you understand the circuit that you're working with. Be safe. Never reach on anything that is going to have live voltage that is dangerous to you. If you do this, you're doing so at your own risk. I'm just warning you up front. But you know, these are lower voltage devices. This is a lot of the times these are connected to ground unless it's a negative power supply. Then these can actually be live. But again, the one hand rule, you only touch it with the one hand. The other hand is behind your back. You do not touch anything ground. But best thing is, if you're not comfortable and haven't worked with this for many years and understand the circuitry and how it works, don't ever do that at all. Another option would be, I'll show you, to use one of these. Okay, so what this is an infrared thermometer, and you can see there it focused, and if we squeeze that, it tells you the temperature. If you look down here, that has a little laser light. Whatever that light is on is what you're measuring, and you can actually take a measurement of the temperature. Come on and focus. And that's a safer way to do it. But regardless, you can check the temperature of these. The other thing is, turn it on, run it for a while, shut it off, unplug it, and whatever. The point, and don't do that in tube gear, by the way, guys. Vacuum tubes have very high voltages, very dangerous. I probably shouldn't have even broached this subject, because I'm sure everybody will be coming on and saying, hey, you shouldn't be telling people to do that. So anyways, what I am telling you is, if you're not comfortable working around electricity and don't understand it enough to be safe with it, then don't do it. Let the professionals do it. That's why we make these videos, to entertain you and to show you the process. And for those of you who do know how to work with it, you know what to do. Okay, so anyways, I beat a dead horse on that. So, you want to kind of check and see if these get warm. The way I powered this up is I connected this to a dim bulb and turned it on, and just, the thing came on. It did make sound. I was able to get it to work somewhat. The controls are very scratchy and need cleaned and things like that. But the biggest issue was some of the caps, one of the caps in particular underneath, was getting warm. And that's one thing I always check for when I first turn on a new receiver that I haven't worked on yet. I power it up, I check the temperatures of the capacitors, see if any of them are bad. I always have it on a dim bulb tester. Therefore, if something does short out, or if a capacitor decides to let go as soon as you turn it on, which that happens, guys, I've had it happen many times, you'll be able to, the dim bulb will take up the current, and the rest of the circuit will not, hopefully. You'll notice another thing that's unique that you haven't seen yet, and I don't think in any of the things that I've done videos yet on, these two capacitors are not power supply capacitors. These are actually output coupling capacitors. So in some of these older amps, a very simple, elegant solution was, you notice there's no speaker protect relays or things like that in this, but what they actually do is they put this capacitor in series with your speakers. So you have the output of your channels, your left and right channels. The output goes right through the capacitor and then out to your speakers. What does that do? Well, let's say you have a transistor short out. Okay, this capacitor is going to decouple that DC from your speaker. So it's going to work like a speaker protect circuit. What if this thing is not DC balanced properly? Again, this will provide isolation. Now, the capacitor is a high enough value that it can carry the amount of current that it needs to drive the speaker load that this circuit was built for. So it's usually, these are usually large, you know, they can be up in the thousands of microfarads. These ones are 2200 microfarads, I think, at 35 volts. So the downside is, obviously, you're putting a component in line with your speaker, and these can theoretically color the sound, right? So depending on the ESR, these are usually very low ESR, very high quality capacitors. I will not replace these if they test good, because you need special ones that are, these are directly in the audio path. They have to be good quality. You can't just take any cheap power supply capacitor off the shelf. It would work, but it would probably color the sound even more than good quality ones do. So these usually don't go bad. They usually don't short out. They don't have constant DC on them like you would see in a power supply. So like in like in this one, which is your main filter cap, this one will get replaced. So just to give you a little heads up. So we'll look at some of this. What else? If you notice, pretty decent sized transformer for a little amp, you know. These have the old style light bulbs that look like, kind of look like AGC fuses. So, you know, you can order, they actually make really nice looking LED replacements that make these a really bright, beautiful blue colored dial readout. Sometimes we can change those out, but this one, all the bulbs seem to be good in it. Your tuner section right here, and you can see it's actually a relatively good tuner. Has really nice IF cans that are easy to adjust. Everything's right here and easy to adjust. It does not have the normal traditional ceramic filters that you normally would see, at least that I can see, unless they're down in here, but they're usually out here. I think this is actually the filter. I haven't looked it up, but I think this little epoxy dipped thing is kind of like a predecessor to the little ceramic filters. I'm not sure. Fairly good gang tuner. I think it was a 4 gang or something like that. 1, 2, yeah, something like that. So all in all, pretty good thing. Over here is your, I believe, is your phono section, and you can see it's all sealed up underneath this case. I'm pretty sure that's what's in here is your phono RIAA preamp. You can see we were talking about earlier, okay, about the de-emphasis. This actually has a de-emphasis, but you can see because of this particular model, there's no switch in there. Because this one was made for the USA, it's hardwired, like we were talking in my last video. This one's hardwired for 75 microseconds for the United States and doesn't have the switch on it. The international ones will have, you know, a switch here, and they'll also have a switch on the back to switch between the different voltages for the different countries, like 230, 115, 120, or 100 volt for Japan. And then it would, you know, would have this switch. The ones that are specifically made for Europe would be hardwired for 50 microseconds and would be hardwired for 230 volt or 250 volt AC. So there you have it. So let me get some dust cleaned off of this thing, make it a little neater so we can look at it. I will probably start doing some recapping. And you can see very accessible on the back to work on these. And you can see all the way there. This capacitor here is the one that's getting really warm, and it gets really warm when you turn it on, so I'm not going to mess with it. And this is right on your main power supply. Here's your main your main rectifiers, these funny looking round things. You can kind of see them if it'll zoom in on it. There. See how funny those look? Those are actual diodes. And you have some protection fuses here. And you can see everything's pretty much wide open on here. So really we're not going to have to disassemble a whole lot to just get to these components and recap it. Now, to do the tone control and everything, I'll have to pull these two boards out here, and I will do that. And then we're going to give it a run, and according to the owner, after I do all this, he claims that after this is on for a while, it starts to fail. So not that I'm not really hoping for that, because that's never fun to troubleshoot, but for your sake, if it does have that issue, we'll get to go through some theory of, you know, how to find the leaky transistor, how to troubleshoot it, and then how to choose a suitable replacement. I know I get a lot of questions about what kind of replacements do we use for these, because, you know, either the person, you know, the person that's doing the comment on my channel is either like in a different country, like Europe, you know, instead of being in North America or something like that, or they'll be in South America or whatever, and they may not have access to the 2SA, 2SB, 2SC series transistors like they use in the 2SDs, like they use on this gear. And I'll tell you, there's a lot of choices. You don't have to use the exact part number. There are other manufacturers who make the same silicon, same characteristics, same gain, same voltage and current capabilities, all that in their own brand, whether it be the 2N or the, you know, the BCX or the BC series. Those are all, there are always interchangeable ones. And really the main thing you want to look at is the application of it. And if you can find the specs on the originals, that's even better. Compare them to the ones you have in your country available to you, and usually you can find a suitable replacement. I do it a lot because, quite frankly, a lot of these are, you know, no longer in production. They're getting hard to find. When you can find them, they're very expensive, which kind of, it makes these lower end receivers not worth restoring because of how much it costs to, you know, to get exact name replacements. So if we can find the same or higher quality component that's a different part number that's suitable and works perfectly in there, it's good all around. So let's get this cleaned up. Let's start working on doing some recaps, and then I'll be back. So I get a lot of questions. How do I clean these out? What do I use? Well, one of my favorite tools has become this, and it looks like just a normal artist's paintbrush, but the bristles are really, really soft, exceptionally soft, okay? And actually, I purchased this at a store called IKEA. I don't know if you all have IKEA in your area or if you've ever heard of a store called IKEA, but they're a Swedish furniture store, Swedish-based furniture store. They sell furniture, housewares, things like that. We have one out where we live, not too far away. And I found these brushes. They come in packs of like 3 or 4. They're very inexpensive. They're like maybe $1 or something. And they last a really long time, and they do a great job of cleaning components without damaging them. You know, a lot of paint brushes have kind of stiff, wiry kind of bristles. These are very, very cottony soft, and you can use them to get like inside the components like this and just kind of brush the dust loose. Now, of course, you don't want to go over top of potentiometers a whole lot, the things that you could move. Oh, you know, you got to be really careful in the tuner sections, but like things like this where you're just brushing off some resistors and, you know, the components like that, it's really nice because they kind of glide right over the components without even moving them or disturbing them, which is what you want. Some of this stuff's pretty delicate when you're in there cleaning it, and these work really well. The other thing I'll use is, once I break the dirt loose, you know, I have just a little vacuum cleaner, standard vacuum, but I have a vacuum cleaner that has a wand on the end that has an air vent, and that's really important because if you close this all the way and all the vacuum suction is right here, it can actually put excessive vacuum and pull components loose, which is not a good thing. Whereas if you open this gate a little bit, if you touch it on your hand, the vacuum goes up in here. So it reduces the amount of vacuum enough that it can pick up dust, but it it's not so powerful that it'll suck components off the board. And you can just kind of hover around and it'll just pick up the dust that you're brushing loose. Now, I'm not going to do it on camera because it's really loud running the vacuum and everything, but it just gives you a little idea of some of the process of going through, the cleaning process. The thick dirt like this, you can kind of brush it up and get it loose with these. And then, the finer dust and things you can get in there with a little polishing cloth or a little paper towel or something and clean it up. But that seems to be the best process for me. I'm sure you can find these kinds of brushes in art supply stores and things as well. But the thing impresses me most about these is how soft these little bristles are and how fine they are. See how fine? They're just really super fine bristles. So just thought I'd share that with you. So let me continue cleaning this and get some caps replaced, and we'll be back. Okay, so we have the power supply recapped, as you can see there. And I replaced these little, these are some early silicon high current diodes. And those were originally the main diodes for the, the main DC rail. And as you can see, I put some much beefier ones in there. And the reason I did that is I also replaced this original, this was at the customer's request, the 3300 microfarad main capacitor. And look how big this thing is. Let me back up. You can see how large this thing is for being only a 3300 microfarad. You can tell how old it is. It still reads good, but as the owner said, how long will it read good? Maybe another couple years, maybe 1 year, maybe 10. They don't know, but he's kind of the camp where he wants to fix it and be done with it forever. So I replaced the cap with one that I had in stock. I had to make a little adapter plate, and you'll see why here when we get this flipped around. Kind of hard to do with the camera in the way in front of me. Alright, so you can see the new capacitor is much smaller, and you might say, why did you put a smaller capacitor in? But here they are, side by side. But even though this one is rated at 3300, this one here, if you look very closely, I don't know if it'll focus. Sure it will. 6800. So this is 3 times the capacity of this original one at the same voltage, 63 volts. And I had a little bit of concern, although it probably would have been just fine. I had a little bit of concern using these older diodes because the inrush current of this new capacitor is much higher, will be much higher than this older one. So even though the physical sizes are different, this is a much more efficient, much more 3 times the capacity capacitor. It's a Nichicon. It's 103 degree Fahrenheit cap versus this one, which is an 85 degree, I think. Or, I'm not sure. So that'll last forever, and it'll also give a lot more reserve to the power amplifier here, so that during, when you're heavy bass or whatever, you'll have plenty of capacity to handle it. So it's actually an improvement, even though it's physically smaller. That's just how much more efficient everything has gotten. So I had to make, as it was a smaller diameter, I had to make a little adapter plate, and I just used a little piece of PC board material, and I soldered the bracket for the new smaller size bracket to that, drilled out some holes to fit in. So this is all on a ground plane, and mounted this up. So we're good. And I tested it, and our 48 volts is rock solid and looks good. So we're going to move on and start doing the power amp now. Well, I have this thing all recapped, and everything turned out really good. It sounds fantastic. I've not done any alignment yet, so the bias and everything is not set. But it sounds really good, but there is, I think I see what the owner's talking about. There is a really serious problem in the tuner. Now, I'll kind of try to, this camera has stereo microphone, and it does a pretty good job. I hope we can pick it up if you're listening in stereo. But basically, I think there's a problem with the multiplex circuit. And you can hear it pretty clearly when you turn this on. Of course, there's going to be music, so we're going to have to just play it for a second. I don't want to get flagged. But I'll give you an idea if we can hear it. Now, it's on mono right now, and I'm going to switch it over to stereo, and you'll hear it.
We'll keep in mind that it's
there's mono
that brought you to us.
Stereo.
4.5 3WS.
Mono, stereo. So what it's doing is when we're going into stereo, we're getting left channel, and the right channel is getting really, really dim, weak. Now the receiver has very good sensitivity, good selectivity. I don't think there's anything wrong in the front end of the tuner. I think all the problems are in the multiplex circuit probably, or maybe the discriminator is off center a little bit. So we're going to have to do a little bit of troubleshooting on that. As you can notice, I have not recapped the tuner. I've not done anything to it yet. I've done power supply, I've done the amplifier, and I still need to do the phono stage yet. I did do the tone control and volume control, and the control amp, as they call it. That's been all recapped. All the pots were pretty dry, so much so that and one of them had a little cracked solder joint right on the one of the terminals. So I just went ahead and removed them, cleaned them properly, and soldered them back in the correct way, so they'll last a long time now. Put deoxit on them. They're working perfectly now. So that's where we are at the moment. So we're going to go ahead and I'm going to do the phono stage before I forget, and then I'm going to dig into this tuner, and we're going to probably have to connect some test gear to actually visually see what's going on. This is not something we're going to be able to poke around. We're going to need to get some test equipment out. So stay tuned, and that's where we're headed. Okay, well, it's been a few days here since the last video that the last clip that I shot, and where I left off with this was I went ahead and I recapped, or at least replaced the electrolytics in the tuner section. There were a whole ton of these little 0.47 microfarad. I think this is a 0.47. Yeah, that's a 4.7. Hold on. Let's see if I can find one here. There they are. A whole bunch of these. And as you can see, they're 4.7 microfarad. There you go. And they're electrolytics, and they're notorious for having leakage, and they do affect the sound. They'll make it sound kind of just they go bad. So I replaced those with film capacitors, and you can see these, they'll last forever. You'll never have another problem with them. A whole bunch of them in there. So those are all done, and the alignment surprisingly is pretty good. And beyond recapping it, I also cleaned the selector switch, which is over here, that selects the AM, FM, phono, all that. And between cleaning that switch and putting the deoxit on there and recapping this, it made a surprising difference in the tuner. The tuner does mostly work now. The alignment is pretty good. Just doing a preliminary check out. Okay, we don't know. We haven't done a whole lot of testing with test equipment yet, but just hooking up a signal generator, it's okay. One thing that I noticed was I'm never getting a stereo indication. So, and one of the bulbs in the dial indicator was burned out. So I replaced that. I mean, you can see it's pretty toasty. So I replaced that. And where we are right now is we can turn the receiver on. We can tune in a station, a stereo station. I know with my test equipment that I have a multiplex stereo signal right now connected, and I'm getting no stereo indication whatsoever. So that's where we're at. Let's move this back here a little bit. I'm coming out of the auxiliary tape, or the tape recorder out jacks, okay? So this is just a representation of what's coming out of the preamp. And I'm connecting it directly into the 2 channels of one of my oscilloscopes. So we're looking at, right now, just at the signal that we're tuning in on the scope. If you look up here, as always, have the standard, the HP signal generator, and I'm modulating it with the multiplex signal from the SG165 over here. Okay, let's see, way up here. There it is. And it's just set to standard multiplex. I have left and right channels out, and of course you have your 19 kilohertz pilot. If you guys don't know the terminology that I'm using right now, I suggest that you go back through some of my videos and look at the SX1050 restoration video, and look at the my follow-up on stereo multiplex and how it works. It'll give you a little more understanding of what I'm talking about. So let's turn this on, okay, and let's plug it in. And you can see right now that we do not have anything but static right now. Okay, so right now we're set at 98 megahertz, and I'm not tuned in, so let's tune on to that. And you can see when I tune to 98 megahertz, I am getting a stereo signal right and left. And if I turn left off and I turn right off, you can see I am in fact getting stereo, okay? But I'm getting no stereo indicator. So if we look down here, I'm sorry I'm moving the camera a lot, but you need to see all the different locations. Okay, right above where it says 88, okay, we should be seeing a stereo signal, okay. I'm feeding 1 millivolt, which is approximately, or 1 microvolt, I'm sorry. It's a pretty strong signal in there, and you can see the meter is not really in where I think it should be, but it is a good solid signal. And I'm not getting, any kind of, I mean, you can hear it. There's a wee little bit of static, but it's a plenty clear signal, and I'm not getting any kind of stereo indication whatsoever. So first thing we want to check is our bulb, right? So let's shut everything off. Now if we look here, here are the 2 terminal posts for your stereo indicator bulb. And the first thing we're going to do is just a quick little check to see if the bulb itself is bad. Okay, so see if I can get everything in the shot here. And we can just hook right across these terminals. And you can see that's mega ohms. Alright. So, as you can see, there is, you know, megs. So the bulb is burned out. So the first thing we want to do is, let's get that bulb replaced and see what happens. Now, the other thing we can do is we can go to voltage, and what should happen is, even though the bulb's burned out, I should be able to tune on and off of this channel, and I should see the stereo indicator come on and off. So let's turn this on. And if you look, I have negative 10 volt. Of course, it's just how I have my probes hooked up. But I have 10 volts sitting there, which that should light up that bulb. And if I tune off the signal, so let's turn some volume up. You can hear I'm tuned on it. When I turn off of it, nothing but static. The stereo light should turn off. So the stereo indicator is not working. That's what this is telling me. And if you look, and I kind of suspected something like this might happen before we even tested anything, because if you look at these, let me turn power off again. If you look at these wires here, you see how these ones are real yellowed and kind of cooked a little bit? And you look at all these other wires, and they're a little bit aged, but they're more, you know, white colored wires. This wire, this light has been on for a very, very long time until eventually it just burned out. It was getting hot. And I suspect these are 8-volt lights, and if you notice, there was a full 10 volts on that. So there's obviously something wrong in that circuit that we're going to need to troubleshoot. Stereo is working, it's the indicator that's not working. So let's pull some schematics and see if we can make some sense of why it's doing what it's doing. Alright, we have the schematics here. And I'm trying to get the lighting a little bit better, but it is what it is. So when we look at the schematics, down here at the bottom, you can see pin 1 off of the tuner board there. You have your IND for indicator light. Okay, so that's your first thing. And if we follow up here, all there is a simple transistor going to ground. Okay, there's no there's no current limiting, there's nothing. It's just, I drew this part in. This goes back to the power supply board, and you have your 8 volts AC. You have D5, which is just a single diode. So it's a half-wave rectifier is all this is. So I have 8 volts with reference to ground, AC, being half-wave rectified. It goes straight into the light bulb and into this. So the current path would be through the diode, through the bulb, up here through the transistor. If the transistor is biased on, it acts like a switch. So it's just an on and off state. Okay, this really isn't a biased, you know, circuit. It's just full on, full off. And if you look here, all you really have is a capacitor, and you have this driver transistor with a little 100 ohm resistor to turn this transistor on. Okay, and this is connected up. If we look up here, this is your 19 kilohertz pilot. Now remember from previous videos that the way, and again, this is the most basic analog stereo multiplex circuit. Okay, there's no chips, there's no integrated circuits in this. It's all analog discrete components. And so the way a multiplex circuit functions is if it sees a 19 kilohertz tone carrying on top of your carrier signal. So in other words, you have your 98 megahertz station. Okay, so our channel that we're tuned into right now is 98 megahertz, which is what my signal generator is putting out right now, right? And my SG165 multiplex generator is producing a 19 kilohertz tone. It's a continuous wave 19 kilohertz that's modulating, FM modulating on that 98 megahertz station. So this transformer picks that 19 kilohertz off. When it sees that 19 kilohertz, that tells the tuner, hey, this is a stereo station, it's not a mono station, which in turn will cause a voltage to turn on this little transistor, which will turn on this bigger transistor, which will turn on the light to tell you that there's a 19 kilohertz pilot and that, yes, in fact, this is a stereo station. Okay. Now, other things take place afterwards, you know, your frequency doubler, your 38 kilohertz, all this, to get your right and left channel, and you can see this is where that's taking place. But you can, I'm not going to redo all that. That's a big dissertation on how multiplex works. Look at my videos on that, and you know, if you're not familiar with it. But really all we're interested in is this transistor here switching? And is this transistor here switching? That's really what we want to know. So we're going to look at this Q11 and Q12, and we're going to look and see if in fact one of them possibly could be bad. And I'm suspecting that this transistor here is bad. Okay, so before we go and replace the bulb or do anything like that, we're going to troubleshoot this little circuit. Okay, so that's where we're going to go. Okay, we're looking at the board layout right now, and as you can see, there's Q12 and there's Q11, and you got to remember this board is showing you the foil side, so this is upside down with reference to how we're looking at the tuner board itself in real life. So you kind of have to picture it flipped upside down. Okay, so when we do that, we find that there's Q12 and there's Q11. Okay, so what we want to do is we want to connect our meter there, and the first thing I want to see is if Q11 Q12 is just shorted, so I can measure from the emitter to the collector just putting my meter in diode check with the power turned off. Okay, nothing in the circuit, or nothing turned on, and let's just see what we get. Okay, give me a second. I'm connected between the collector and the emitter of the transistor, and I'm in diode check, and as you can see, it's open. So the transistor is at least not shorted from emitter to collector. Okay, now if we go into, let's now look at base to emitter, and I don't see any shorts there, you can see, and let's go from base to collector, and again, nothing there. You're just reading through some circuitry, capacitor or something, but no shorts. So the transistor is not shorted. Now the next thing we want to check is we're going to go to DC volts, and we are going to put our ground probe on ground, which, let me find ground and get connected up, and I'll be right back. Alright, the tuner is on right now, and I am not on a station, so I should not have, you can hear just static, and I am getting, sorry, I'm losing my voice today. I'm getting about 0.7 volts drop on the base of the transistor. So definitely the transistor is being told to turn on. So now we got to go back to the transistor before that, which would be Q11, and look at that one. Okay, on Q11 it says that there should be 12 volts going into the collector and 14 volts on the emitter, and I would believe that would be when you have a stereo indication. Okay, so I'm now on the collector and I look at the voltage, and of course I do have my 12 volts. Now if this transistor is turned on, I should be able to move to the emitter and it should have that 14 volts on it. So let me move the probe and let's look at that. Okay, we now have the emitter and we do not have 12 volts or 14 volts. We actually have just under a volt. Okay, we have about 900 millivolts. And you can see it's kind of moving around, and if we tune on station, let's see what happens. When we tune on station, it goes to 1 volt. We tune off station and you can see there is a slight change, but not a real distinct change. So now let's look at our base and see what that looks like. Okay, we're now on the base, and you can hear I have static, okay, and I have about 300 to 400 millivolts moving around, and when we tune onto station, we get about 2 volts. So we definitely know that our pilot indication circuit is working. You can see we go, we're roughly 2 volts, 1.8 volts. When I tune off station, it goes away, it drops way down. So that is working, okay? And when I turn off my multiplex, you can see I can just go to a straight mono signal. So it works. Okay? So I'm kind of zeroing in on the fact that probably one of these transistors is failing when it's, when you apply voltage to it. And, touching them, they don't feel warm or anything, but it looks as if one of these 2 transistors is bad. And the reason I believe that is because all the voltage levels are where they're supposed to be. Now, what you have to understand is these 2 transistors interact with one another, so Q11 could possibly be bad, which is causing Q12 to turn on when it's, like it's supposed to. Q12 though could also have a problem, and it could be breaking down under load when you put voltage on it, and it can be shorting back to the base and causing an erroneous signal on Q11. So it could be either or. Now we can try swapping out, one at a time. There's a few different things we can do. We can just swap both. These are very low cost, 50-cent, dollar a piece, transistors. So what I'll most likely do is just replace them both. But we could take it further if we wanted to, try swapping one at a time, things like that, but not worth it in this instance. You spend a lot more time doing that than it makes sense when they're 50-cent parts. So let's get those transistors replaced and see if our indicator works, in which case then we can move on and start checking the alignments. Well, surprise, surprise. I replaced the indicator lamp, as you can see down here, and I went with an LED, obviously. I don't have any more of the little grain of wheat bulbs. But I replaced it, and lo and behold, it is somewhat, at least, working. So let's hook up here. I'll move you down, and we'll see if we can. So you can see the stereo indicator on, and you can hear. And right now, if we tune off station, but if you notice, I have everything turned off and I'm tuned off station, and it is still giving me a stereo indicator, but it does somewhat work. Okay, so you can see I'm tuned on right now to like the sideband, and you can see. So, and I have no 19 kilohertz turned on or anything right now. So as you can see, there is definitely something wrong, and the way it's acting right now, I think what we've got is a alignment problem and not a bad transistor. So we kind of chased our tail for 10 or 15 minutes here on this, but you know, we went through and kind of did some troubleshooting, and that's part of the game, you know. So now that we're out of the rabbit hole, we're going to try to do some basic alignment and see if maybe it's just either the discriminator or the you know, the 19 kilohertz pilot circuit might have some issues. So let's get into some of the alignments and take a look. By the way, before we start, I just want to make a quick note. Some of you may be asking, why in the heck are you connecting the SG165 into the HP8657? Why can't you just use the SG165 by itself? And that's a really good question, in case any of you were thinking that. The 165 can output a stereo signal on an RF carrier. It is capable of that. But it definitely does not have the accuracy of the HP. The one thing, you know, it just has a basic output adjustment. So it's really not very accurate. It's just a knob that you turn to change the output. You can't really set as you can on this one. You know, if you look at the HP, you have total control over the output. So I can set it to millivolt, microvolt, dBm, dBf, dB, basically whatever you want as far as an output, you can set it. Now, of course, this would be terminated into a 50 ohm termination, so you would need the correct cabling, the correct balun to, for the correct coupling to your receiver. But the bottom line is, what is coming out here terminated at 50 ohms is exactly what you're setting on your output amplitude, and you do not have that kind of accurate adjustability on the SG165. Now, the 165 is fine if you're just trying to put a signal into the receiver and get something out. It works. You can turn the knob till you can hear it and all that, and it will suffice. But I kind of like to know where I'm at with things, and the HP's a little bit, since I have it, I'm using it. I guess that's the bottom line, and I'm comfortable with that setup. So hopefully that kind of explains a little bit of why I'm doing it the way I'm doing it. So on to the alignment. So what you're looking at now is is the actual output of the discriminator circuit in this receiver. And I had to go through and kind of improvise a little bit with the alignment. If you look at the way they want you to do the alignment on this receiver, what you'll find is you need some pretty specific test equipment for it to work. And although I do have test equipment capable of producing, a swept 10.7 megahertz signal with markers like the SG165, it does not have enough output to get the signal into the radio in the way that it needs to be. So I've come up with another method. Now this will work for me and for my test equipment, and so if you have similar equipment, this should work for you as well. So first thing we have to do, it's all done right now, but the biggest issue that we're going to have is setting up the IF section on this, because let's look at the schematic. If you look at the way this is set up, they're having you inject your swept 10.7 megahertz in through here. It goes through this transformer, goes through this little MOSFET, or this little FET, and then goes through another transformer into this little transistor. Now, I can inject this 10.7 megahertz from here forward and it works, but if you inject it here, because of these teeny tiny little capacitors, you really need a lot of drive signal. This is 0.000, let's see what it says, 0.001 microfarad. This one is 15 picofarad, and this one is 12 picofarad. And if you look, this is kind of like a, this has to do with your oscillator and with your RF, tuning your RF circuit. And if you look, these are connected together. See, this is a tap on this little transformer. So you're essentially putting a 15 picofarad in series with a 12 picofarad, which means when they're in series, it's going to even be a lower capacitance. So there's a pretty heavy attenuation at 10 megahertz. This is really designed to pass RF. And when I say RF, I mean RF in the VHF bandwidth and the and in broadcast, a lot higher, in this instance than 10.7 megahertz. So they really need a really strong drive signal. If you get a strong enough 10.7 megahertz, it will pass through here and work as they want you to. I just don't have that. So what I did was I injected, well, first of all, let's go back. There is so many things here. This first part I did do the setup. So connect a 0.01 microfarad capacitor between TP1 and ground. So we've done that. So if you look over here, there's your 0.1, and right back here is your actual, everything's kind of precariously balanced here. Here is your TP1. It's just this white wire that sticks up. TP2 is the other white wire sticking up here. Okay, so that's the first thing they have you do. Then they tell you to remove the 4.7 microfarad capacitor from terminal 28. So what they're talking about is this capacitor right here on terminal 28. So that's removed, if you notice. Okay, you desolder that and take it off. That conversely is the output of your FM, your actual FM audio. Okay, after it goes through the detector. Next thing they're going to have you do is switch to mono and turn the tuning knob to the right to set the dial to the high end of the scale. So they actually have you cranking this all the way up to max, like all the way to 108 megahertz. This is where I kind of fall out. I still disconnected the FM meter circuit. Okay, so it says connect the scope input to the FM meter output terminal 18. Okay, so we were monitoring 18 for this. Okay, then disconnect the meter lead, then terminate the meter lead with 4.7K resistor. All of that is done on the underneath of the chassis. That's why this thing's up on its side. So here's the beauty of my new camera mount. I can slide you over, and you can see right here, if I zoom back, there's the tuner board, and you can see pin 18. I had to unwrap. This goes up to the switch for the mono stereo, and this goes to your metering circuit, or up to your meter. And I basically just tacked this 4.7K on there and tied it to ground, okay, just like they said. Then you're actually metering that point. So I'm not there right now because I was doing the discriminator last, but you can take this and you connect to TP18 or to terminal 18. So you can see I'm on terminal 18. Now this is some pretty complicated stuff. So if you're into radio, you can do this. If you're not, this might be a little bit advanced. You may not want to make this your first project for sure. So anyhow, there's terminal 18. We're on it. You can kind of see it. All right. And so the next thing we're going to do is set the scope. All right. You're going to set your scope, and you're basically going to adjust with your 10.7 megahertz. If you have a strong enough signal, you're going to adjust it basically for a maximum deflection. Okay. Again, and you don't want your frequency to drift when 100 dB is applied. So you're adjusting T4, T5, and T6, which is these three down here, T4, T5, and T6. Again, this is where I cut off of there, okay? It's kind of difficult to adjust that the way they want. They want you to actually put up and get an S-curve and get all this. That does not work for me because, again, I did not have the right kind of signal to get that. Okay, so you see how they're showing all of this. There's no way I couldn't do it. So what I did was I input a strong signal, modulated, okay, FM modulated. Remember, they didn't have this kind of, of a setup signal generator. So you can see right now how strong this is. I'm at negative 90 dBm, and if you can hear, even at negative 90 dBm, teeniest little bit of static, but other than that, I'm getting a strong signal. And really the idea behind all of this is if you properly tune it on frequency, you can see that the discriminator should be exactly the same amount positive and negative on your, with respect to ground, with respect to zero, if your discriminator and everything's set up properly. The other thing is, you can see as I just go up even to negative 80 dBm, there's no static. Okay. I'm getting ahead of myself here. So you're looking at that. And hold on a second. All right, so we're on TP18, or should be terminal 18, and the next thing we're going to do is we're going to adjust the FM tracking. Okay, so once again, we just used the FM modulated signal, to align your IF. Now that's not a good way to do it because you don't know if you're dead on 10.7 megahertz, but chances are your receiver, as long as nobody messed with it, is pretty close already. So really, you probably are going to be spot on if you adjust it this way. So you just adjust those three, T4, T5, and T6 for, you know, maximum deflection, and that's really all there is to it on that. Now for the F, then you can go through and do your AM alignment, which is really easy. That one you can follow the directions. It's only a couple of steps. You're just connecting 455 kilohertz signal and you're modulating it and you're peaking your 3 IF coils, which is pretty easy to do. Now, next thing we want to do is we want to adjust our FM tracking, which on this one I'm still on my TP18 or my terminal 18. I keep calling it TP18. It's not really a test point. And as you can see, I'm set to 20 millivolts per division, so it's a very small signal. I'm at 400 microseconds, and that really doesn't matter a whole lot because you're not really looking as much as at a waveform as you are at peaking it out, okay? And the first adjustment they have you do is at 90 megahertz, okay? So you would go down to 90 megahertz and you would adjust these first three adjustments, T1, T2, and T3. Not in that order. You do T3 is your oscillator, T1 is your antenna, T2 is your RF. And you basically peak that out. Then you go to 106 megahertz, which is where I am right now. And it's the same idea, but instead of the coils, you're aligning the capacitors. So we'll adjust one and show you what it does, okay? So if you look, I'm at 106 megahertz. I'm at negative 70 dBm. So I have, you know, a weak signal, but a decent signal. And I FM modulated. I have a 400 hertz tone. You can hear it. Okay, and turn the volume up. And really all we're going to do is we're going to go to our meter. We're going to go to T3, which is your oscillator, and that's what's going to bring it on frequency. So like, let's say you're not tuning it right in at 106 megahertz. Maybe it's a little bit off. You set your tuning scale directly on 106 megahertz, and then you adjust T3, or I'm sorry, CT3, okay, the capacitor CT3, to get you dead on. So between T3 coil and CT3 capacitor at a high range frequency and a low range frequency, you're basically setting your dial accuracy with those two adjustments. So if your dial accuracy is off but everything else is good, that's where you adjust. Now, the next thing you're going to do is set CT1 and CT2. Alright? Just like you set T1 and T2 at 90 megahertz. So I'm right there where we can do that now. And CT1 and CT2 are down here on the tuning coil, or on the tuning capacitor, okay, the tuning gang. And remember, I'm kind of doing this shooting from the hip here, so I have to correct myself as I'm explaining this. But you basically have your CT1 and CT2, alright, which CT1 is this bottom adjuster, and CT2 is this one. See, this is CT4. I don't know why they put them like that, but that's the way it is. So I'm going to adjust this one, then I'm going to adjust this one, okay? And watch what happens to the meter. So first things first, we're on CT1, okay? So let me back you up a little bit so you can see. Okay, CT1. And you can see, watch what happens as I sweep through the peak. See how it goes up and it gets jaggedy. And let me get on peak. and there it gets smoother, and then all of a sudden, see, it starts to come back up again. So you hit that null point, and it's pretty touchy. Okay, so right there, we're pretty close. And if you listen, it should sound pretty clear. And you can see if you get off of it, you can't hear it real good because this is so sensitive. But there you go, you're peaked on. Okay, then you go to the next one, your CT2. Same thing. See how it's off? I'm just rocking that trimmer through its null point, see? So we're going to bring it clear down till it's null. And then we can expand it and get it even a little bit more sensitive to get even more accurately onto the peak. Get right on there and go back and forth and make sure you get both of them perfectly on. And there you go. And that's about it for that. Okay. So those 6 adjustments, they all look like that. It's just 3 of them are on the 90 megahertz, and then these last 3 are 106 megahertz. And once you do that, your selectivity and sensitivity should be set. Now what we're going to worry about is getting our discriminator set properly. Now, very, very, very important for this next adjustment, you cannot move the tuning capacitor at all, or it'll throw your whole setting totally off. Okay, so where it is now, you have to leave it and go straight to this next adjustment. And what we're going to do is we're going to take our probe, we're going to remove it from point 18, and we're going to move it over to test point TP1. And remember, they have you connect this capacitor on here and all this. It's kind of a mess. It's very touchy, but that's what you're going to do. And when you move your meter without adjusting any of your scope settings, this is what you should see, which is your discriminator. Now, from this setting, you want to move your scope down, and you want to put your center line of your scope right at the middle. Okay, so center of the screen. We then want to adjust our amplitude so this waveform fits on the screen properly. Now if you look, we are properly tuned on the frequency, but our discriminator is not set centered right, because this peak needs to be exactly the same amount above the center line as this peak is below. And you can see this one is a little bit too far. So what we're going to do is we're going to go to our discriminator adjustment, which is T7, which is this one right here. See there? Let me back it up. It's this one right here, okay, on this particular receiver. And we're going to go over to here, and we're going to adjust it until it's perfectly centered. See how moving it? And don't worry about this ghosting, it's just the trigger of the scope. And you can see now we've just about brought it right in. That's about it right there on center. That's going to give you the least amount of distortion when you're tuned on station. Now this is really important. If you don't do these things like this, what's going to happen is when you do go to align your multiplex, this will cause all kind of problems with your stereo, okay, especially with distortion and things. It'll give you distortion in mono, but it'll really go crazy in stereo. So this has to be dead on. It always has to be done prior to messing around with your multiplex circuit. Now that this is all set, okay, what we want to do is we want to go and tune around and just see if what we did fixed it, okay, at least got everything aligned. Okay, so we're just going to connect an antenna, and we're going to do a little tuning sweep and just see how the receiver responds. Okay, let me back up a little bit. Get this swung around a little bit. Okay, so I have the thing still on its side, and we're actually going to do a tuning sweep. I have the outside antenna connected, so you can hear. All right, and okay. There's a good station. We don't get a whole lot of stations down here, but we get a few strong ones. The rest of them are kind of staticky.
$40 million Americans woke up to a Gillette shave. And to bring you America's #1 shave for less. Go to GilletteOnDemand.com and get your first and fourth order free.
Concerts. Hey guys, I'm Justin Bieber. Contest. You say, come over and spend the night.
So as we can see, it's tuning really well. For where I live, this is fantastic reception, but we've got a problem, and I'll show you what that problem is. As you can see, no matter where I am, first of all, this is set to mono. So if I go up here and you look at the knob, it is on mono. I have this set to mono, and regardless, no matter where I am, any station, always that stereo signal comes up. See? So what that's telling me is that the multiplex circuit, especially the pilot circuit, is still not working properly. And that's okay, because you got to do this one step at a time. We know that our tuner is sensitive. We know that it is properly tuning in the correct frequencies, and all that's good. So now what we have to do is we can now go through and do our multiplex alignment. Okay, so I know our original problem was that the stereo wasn't working, but prior to doing that, you have to go through all this and make sure that the tuner, you know, your IF section, your discriminator section, and your front end, your RF, is all proper and aligned before you even think about starting to do the stereo multiplex alignment. So I'm confident that we're there now, so we're going to move forward with the multiplex. And you can see what a pain this is to do. Again, it's not straightforward, and the procedure that you have in the book may not match the test equipment that you have, and you have to kind of modify what you're doing, you know, to fit your test equipment. So let's get set up for our next step here and see if we can fix that stereo indicator. Alright, we're all set up for the last alignment, and I've gone through it already, but I'm going to show you what I did. The first thing you're going to do is connect your scope to TP2, which is this other little wire sticking up here. Okay, so there's TP1 and TP2. This is TP1 is kind of like your discriminator, and TP2 is your multiplex. So there it is set up, and again, we're at 98 megahertz, and we have a modulated signal going in from the SG165, and you can see it's just wire coming out of here. We're set at multiplex signal. So I have a 19 kilohertz, and I have right and left, and right and left are turned off right now, so I'm not doing any modulation. I'm just putting out my 19 kilohertz pilot. And when we go over here, this actually shows you your pilot circuit right after it goes through the doubler. and becomes 38 kilohertz. And you can see it's right at 38 perfectly. Okay, and then you're just going to adjust those 3 coils. So you can see we have one transformer here, one here, and one here. And they were out, 2 of them were out really bad. One of them was out just a little bit, and that was our big problem. So I'll adjust one just to kind of show you what it looks like. So here's the first one, which is T13. Okay, and when you adjust it, you can see this kind of squishes down. And if I go the other direction, I peak it out and then it starts going down again. So all we're going to do is find that null point right there. Then we go to the next one. And this one was really out. It was kind of right about there when I started. So, and you can see right about there's our peak. And then this last one was out a really good bit too. And you can see it's peaked out. Okay, simple as that. Now, here's the cool thing. Now that we've done all this, you can hear I have my signal and I'm tuned in, and you can see I have my stereo signal. Let me drop it down a little more. And there's our stereo indicator, correct? And my pilot is on. If I shut the pilot off and just go to a carrier, there you go. It goes away. Okay? You can see it is gone now. If I turn the carrier back on, or I mean the pilot back on, stereo comes back on. That is what's supposed to happen. And that is what was not happening before. What was happening is this, even when there was no pilot, if there was an FM carrier, this stereo indicator would trip on. This is kind of an odd tuner, the way this thing's designed. They've cut, because this is a lower end unit, they've, some of the phase lock loop and so forth is not there that would be on some of the higher end units. So this is a good receiver. It's sensitive, but you have to really make sure that all these analog adjustments are dead on. And unfortunately, the test setup that they have you do is based upon the test equipment that Pioneer was using. And if you don't have that same equipment, you can see how complicated and confusing it can be to try to translate what they were saying into something that you can understand on with your test equipment. Okay, that's why a lot of people, I get a lot of comments, can you please do more detail on how to hook up your test equipment? And so that's what I tried to do this time. But as you can see, I chose this receiver as an example for this to show you that you can't just follow the book all the time, because you kind of have to understand how all this works to translate it into what you've got on your bench, and do it in a way that you understand. And that's not always easy to do. So I hope that this, I don't expect this to be a training video, I just kind of let you sit in on how I do it, to give you an idea of what's involved in setting up a tuner. Now you can go back to some of my other videos, like the SX750, the 450, the Kenwood that I did, I think it was a KR 7400. I did 2 different SX 1050s. I did a whole bunch of tuners, and you can tell each one was a little different, but this was the most challenging of all of them. And so let's hook up an antenna, and I should be able to hear the stereo kick in and out. Now you're not going to hear it on your end because of the way the microphone works and everything, but I'll let you know what it's doing here. Okay, so I have my antenna set up again. You can hear I'm off station, and you can see my stereo indicators off. And you can see it comes right in. And now there's really, really good stereo separation. Now it's excellent. And if I hit the mono button, I can actually hear it go into mono and stereo. Very good. And you can see, even with a lower signal strength, I'm still picking up stereo separation pretty well. And unfortunately, another corner that they cut on this receiver is you cannot adjust the metering circuit, you know, to set it with a certain input to be a signal level 5. It's all preset with resistors and things. You cannot adjust the muting circuit. You can test it, but FM muting is hardwired in there for a 16 dB input, and anything below that it mutes out. Again, if it's off, you cannot adjust it. It just is what it is. So they have cut some corners on this, but it is pretty amazing how many channels you can pick up with this and how sensitive it is and how selective it is. Considering it's only got one filter in it, it doesn't have like a whole gang of filters and things. But all in all, very good tuner, very good receiver. Last but not least, before we button this up and call this video, that's really long, call it a wrap, we're going to adjust the bias. And I saved that for last because, number one, we don't really have to worry about DC on the terminals with this type of amplifier, because you have these capacitors that isolate the receiver, you know, the transistors, the outputs from the speakers. So even if this had pure DC on it, these capacitors would block it from your speakers, and you really don't have anything to worry about. So really the only purpose for the bias adjustment on this is, number one, to keep your transistors from running too hot, and number two, to eliminate distortion at low volume levels. If your bias is wrong, it can affect the distortion that you have at low volume levels. So you want to kind of set that. Now, there's no procedure in the book. They don't even talk about these pots. It's like they don't even exist. But there is a means to be able to adjust it, and they put really nice test points. I wish all of them were built like this, but they just don't have a procedure. And if you look up in here, you have the two pots, 1, 2 for right and left channel. And then if you look up inside here, you have two very nice sets of test points. Right here's a set, and right here's a set, and you just connect a millivolt meter right to that, and it gives you a direct readout of your bias voltage, okay? Which I'm probably going to set it somewhere around 30 millivolts and test it and see how it is. Most of the other receivers in this generation that do have procedures, that's kind of where they want it as far as the, you know, the bias. So I'm going to do a little trial and error. I'm going to set it, and we're going to listen to it and check for distortion and at low level, and then we're going to let it idle for a while and make sure the transistors don't get hot. So let me get set up and we'll do that. Okay, I just connected this up. I haven't touched anything, and I just kind of, this is warmed up nice. We've been playing it for a while. And you can see I was saying 30. They have it set right now at 35. I'm going to drop it down to 30 because I think that once again, I think that'll be fine. And we'll check the other channel and see what it's like as well. Right around there. Good. And there's kind of a little bit of a delayed reaction. Let's go a little above. And you can see, whoop, easy to jump. There we go. I'm going to leave that right about there. And now we'll move it over to the other test point for the other channel. Like I said, it's really easy on these ones. Okay. And you can see that one's a little bit lower. So one was a little above, one was a little bit below. You just barely have to touch these to get them where they need to be. All right, that's good. We're just going to leave those alone. And those are good. So like I said, this thing sounded... Okay, so we're in dual camera mode, and what you see on the oscilloscope is the actual waveform coming out of the amplifier. And our first test that we're doing here on this amp is going to be distortion at very low volume, which is what I was concerned about with the bias. So right now what we have up there is I'm putting about 1 volt peak to peak, which is about 125 milliwatts of power, which is very, very low power. So it's very low listening level. Okay, that would be a very quiet room with very low volume. And up here we have the distortion meter, and it's bouncing around because everything's so sensitive right now. I'm on the 0.1% setting. And, you know, things are varying, you know, even the variance in the frequency and all that will throw this off. So if you look here, you can see. So we're getting somewhere, it'll bounce down to between, and this is 0.04% distortion, 0.06. So it's staying between 0.05 and 0.07% harmonic distortion on, you know, with only 125 milliwatts. And again, it's such a low signal that it's actually difficult for the you know, for the test equipment to pick it up, because even dirty contacts on it, you know, not making good contacts, or your cabling, everything plays a role in that. So the bottom line is, I'm very happy with the distortion. It's way, 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 way below. It's even below 0.1%. So I think our bias setting was fine right where it is. So we're going to leave it right there. Next thing we're going to look at is maximum power. So let's go do that next. Okay, so I'm not going to leave this on for very long because it's running at max power, but we're running 11 volts. Okay, and that's RMS. So we're getting about 15.1 watts per channel, which is really good. And you can see our distortion. I'm on the 0.3% scale, so that would be 0.1, that would be 0.2, so it's about 0.135% distortion at max at 15 watts per channel. So for a little amp that's rated somewhere around the 10 watt range, very impressive. If you look over here at the heat sinks, I mean, they're barely warm, and this has been running at full power now for a couple of minutes. So I'm very, very pleased with this amplifier, how it performs. Now the next thing I want to do is that's at 1 kilohertz. So we're going to disconnect our distortion meter. We don't really need it right now. I'm not going to mess with that. And I'm just going to see, we're going to run the range. We're going to go between 20 hertz. Okay, so we're going to go frequency. We're going to go 20 hertz. There you go, align phase. And then we're going to move our scope over here. we go. And crank our power up and see if we can get, it distorts quite a bit there, but let's see if we can get our 11 volts without distorting. There's 11.1, there's 10.4, you can see. And so we're getting a little bit of distortion there. So at 20 hertz, we're getting roughly 10. We're getting right 10.058 volts. Okay, so we're getting about 12.5 watts, which again, this is a 10 watt rated amplifier. So we can easily do about 12 watts clean at 20 hertz. And that's pretty good. I mean, remember, that distortion you were seeing is most likely those output decoupling capacitors. That's most likely what's the problem. So now let's switch up to, let's go to 20 kilohertz. Okay. And we're going to move the frequency open. And we're going to, sorry about that, we're going to crank that up. And once again, 11.7 volts, so a little bit over that 12.5 watts. So this thing, I'll call it 12 watts per channel clean from 20 to 20 kilohertz. That's not bad. So yeah, I think this is going to be a great sounding little receiver, and I think the owner is going to be really happy with it. This thing's keeping up with the big boys, just lower wattage. That's it. All right, so we're done with the testing, and I think we're about ready to wrap things up. So this was quite, an involved repair. There was quite a few things that we had to do. We had the recap to deal with. We put a new main filter capacitor at the owner's request. We did a full tuner alignment, and of course you could see where that got really complicated. I put a lot of off-camera time into that, figuring it out, but it turned out really well. We replaced a bulb in the display, cleaned up some solder joints, a few things like that. But all in all now, this receiver is ready to go. It's in fantastic shape now. All the dust is cleaned off. Everything's good. So I hope you enjoyed this video. Hope you learned a few things, and plenty more to come. We got a whole bunch of things. The next project I have is an old oscilloscope I want to restore, and then I want to do a short series on oscilloscopes, how to use them. I've gotten a ton of requests, and I have some people at work who really need a refresher and are asking for a refresher on some scope theory. And so we're going to get into that next, and kind of give the tuner and receiver thing a rest for a little bit, but I'm sure not for very long, because seems to be a lot of them coming in for repairs. But anyhow, if you enjoyed this, give us a thumbs up, and I hope you enjoyed it, and more to come later. And by the way, this I still need to do the cleaning of the knobs, and I'm going to soak those the same way like we did in the last video. And there you go. So have a great day. I wish you all well, wish you all great health and joy and peace in your lives, and remember, don't keep the faith, share it with others. Bye-bye.